Okay guys, so today we are going to derive about perfect gas equation. Okay, this perfect gas equation. Okay, so first of all, what is perfect gas? A perfect gas is one whose molecules are free from molecular attraction and obeys the gas laws at all values of temperature and pressure. Okay, a perfect gas kan ti chu gas ani maya gas mi zo tong chun gas fu lutuk chalutuk perfect gas ani ber chu free from intermolecular attraction anti an mali ne an mani kha in hip ton na le in ti boina engma omlem lova chun gas law ama kan soi to kha in la rianga Boyle's law te Charles law te Gay-Lussac's law te kha an obey vek khatiang gas tralutuk timai tiang hati nge behavior po fu lutuk takmai khati nge perfect gas ani ni masala tak taka chuan in practice the gases do not obey the gas law at all values of pressure and temperature tinia tak taka chuan gas law song song hi gas te hian an obey theilo hai kan room chunga te po gas chu oma hydrogen oxygen chi rang nitrogen te tam tak oma gas rang oma carbon dioxide te chung gas law khan obey vek theilo intermolecular attraction kha om tho ani khang tiang kha khang ka chu perfect gas ani lo amaro chu tuna big chuan perfect gas sangin a situation biga khan perfect gas sangin kan ngai photanga chu a formula I can derive don ani. So first we shall consider let us consider 1 mole of a perfect gas. Okay, I shall write like this as a container in order to understand as simplicity, so that there is a gas here, gas here up to this. So and first of all here the pressure, we know the thermodynamic variables, pressure, volume, temperature, like that we have so many thermodynamic variables, but first only we are going to derive under this gas law P, pressure, V, and volume, and T, temperature. Okay, the relationship between this, and in relationship danaka can derive down to any better. So first of all we considered gas, 1 mole of gas, perfect gas. Okay, so where its pressure is P1, let's say pressure is P1 and its volume is V1 and its temperature is T1. Okay, so its temperature is T1, like this, temperature T1 in the beginning. Okay, so this case, so in step 1, let's say in step 1, so now suppose that the temperature of the gas remain constant. Okay, at T1 is the remaining constant, and pressure is changed from, let's say pressure is changed from P1 to P2, so that the volume of the gas changes from V1 to, let's say, up to the volume of the gas change, it is expanded, is V prime, let's say. So the new volume is V prime, okay, V, and this is P2. So we increase the pressure and the volume is changed while the temperature remaining constant. So this kind of system, changing of gas, there is one law pakhat omani chu hang a change of state of gas kanti ahian from increase in pressure and increase in volume while temperature remaining constant kanti hi chu Boyle's law kanti khanitani. So we have here Boyle's law. Okay, so in step 1 from Boyle's law we have, from Boyle's law, this is one of the gas law, fundamental law of, we have P1 V1 equal to P2 V prime. So this is the equation number 1, P1 V1 equal to P2 V prime. This is according to Boyle's law, while T constant, temperature constant, remaining constant. Okay, so now we're in step number 2. Step number 2. Now the pressure of the volume, let's say P2. Okay, now we will keep pressure of the volume remain constant. Okay, remain constant, P2 constant. But what about the volume and the temperature? So we're going to change the temperature. Before it was constant, now we're going to change temperature. What will be the result of the volume? Okay, result of the volume. So the pressure P2 is kept at constant, and temperature of the gas is changed from T1 to here, T1 to T2. Okay, T2 is changed. Temperature can change T2. Then what will happen is gas will also expanded, and now from V prime to the gas is again expanded to V2. Volumes change. Volume will change. So you can see the volume is changing while if we increase its temperature from T1 to T2. Okay, so according to Charles, we have Charles law. From Charles law we have what do we have? So V prime T1. So Charles law is the relationship between volume and temperature while pressure remaining constant. So this is about Charles law, the second law of the gas. Okay, so this is equation number 2. Let's say this is equation number 2, or we can write, instead of this we can write like this, as because we need this one, V equal to V2, this V2 into T1 will go up, T1, and here is T1 down, T2 down, like this. Okay, so we have this equation number, let's say 3. Now we are going to substitute this value of V, the change of volume, in the first cases in the step number 1, while temperature is constant. So we will put this value of volume into this equation number 1. Okay, here we will substitute. Now let's substitute. Okay, let's substitute. So substituting equation 3 in equation 1, we get P1 V1 equal to P2, this one, into V2 into T1 by T2. Okay, into T2. Now this T1 will come down. Let's say here we put here, or P1 V1 T1 equal to P2 V2 by T2. Okay, so this means that if there is volume 1, volume 2, pressure 1, pressure 2, T1, T2, so we can see the arrangement, same arrangement in unchained range time to PV by T, PV by T. So if there's PT V3 by T3, P4 V4 by T4, it will go on like that. That means in general we can write like this: in general PV by T equal to, that means it is constant, isn't it? It will go on, and same thing, P3 V3 by T3, same thing. So this means that it is constant. So PV by T equal to constant. So this is, let's say this is equation number 4. Equation number 4. Okay. So in this above equation, for 1 mole of a gas, the constant is denoted by R. Okay, denoted by, so constant is R. Let's put, so PV by T equal to R. And now let's rearrange. Okay, let's rearrange here. In the next pages, the next page I shall rearrange like this: P V by T equal to R, P V equal to R T. So this is the final gas equation. I think it is equation number 6. This is the final gas equation. So PV equal to RT is the called perfect gas equation. Perfect gas equation. So we derive the gas equation, very popular formula for 1 mole of a gas. Okay, for 1 mole of gas. And also if V is volume of 1 mole of the gas, and if the mass of the gas is mu moles, if the mass, let's say if the mass of, this is for 1 mole of a gas, but for mass of a, if the mass of the gas is mu moles or n moles, we can say like that also, mu moles or n moles. We can put different notations if we like. So it will become like this: PV equal to and mu RT. So this is also the gas equations where mu is the mass of the gas in mu moles. Okay, for 1 moles of gas we know that PV equal to RT, but if there some other moles, so if V is the volume of a gas in mu moles, so this is also a valid equation. This is also, so this equation 7 is also valid equation in terms of the gas in mu moles, and whereas this is in terms of 1 mole of a gas. So this is also a valid equation. So this is very, very important formula under behavior of a gas. Okay, so that is all about gas equations. That's all for today. Thank you.